denominator of our fractions. If you have a square root, we're just going to multiply to get rid of it. What if I have like addition of square roots in my denominator? Do you know what I would do to get rid of that? Any suggestions? Chase, what do you think?
Well, I know what to do.
Okay.
Just multiply by square radical x minus radical y.
Because it's kind of like the conjugate, right? It is the conjugate, really. It's just a square root in the front. It's going to work out because when you take the square root of x times the square root of x, is that going to get rid of the square root of x for that? What is the square root of x times the square root of x?
All juniors, you should have your picture taken. This is the last call for all juniors, so please report to the comments to get your picture taken.
But you have to do the top two. The top's really easy when it's just one up there, right? The top just becomes square root of x minus square root of y. And again, you could FOIL this all out, but have we talked about conjugates in here yet? I thought we did. We did square root stuff once, maybe? I don't know. When you take something times its conjugate, the middle part cancels out, right? It's like the difference of two squares, really. The plus and the minus make the middle part cancel out. I'll work it out this one time, but just know I never work out the middle part for this, because I always know it's going to just be this times this. Square root of x times the square root of x is the square root of x squared, which is just x, right? How do you get rid of a square root? You multiply by the square root. The middle part, the square root of x times the negative square root of y is going to be negative square root of xy. This times this is going to be positive square root of xy. That's what makes conjugates so amazing. That's always going to cancel out. And then square root of y times negative square root of y is going to be negative what? Just y. So the reason that conjugates are so great for both getting rid of imaginary numbers and radicals is that middle part's going to cancel out. So the answer there is square root of x minus square root of y over x minus y. And that's just the answer that we want because we like simplifying so that the radicals are in the numerator. Right? That's not so bad to start with, right? All right. Questions on that one? Multiply by the conjugate. Whatever's in the denominator, you usually just change a sign in the middle and it's going to work. All right, let's get more exciting. Like this one. I'm going to explain in a minute like what this is. This is like one step away from doing calculus. That's exciting, right? If I said h isn't allowed to equal 0, let's simplify this. Basically, I want to get to a point that I could plug 0 in. Like right now, if we plug 0 in, you just get it, like, it's nothing, like it's undefined. So we want to try to simplify this. And another way to think about this is called rationalizing the numerator. Which is kind of silly because we've always talked about we want to rationalize the denominator. But in calculus, right, this class is like the class that's the prerequisite for calculus. Maybe you're never going to take calculus, but the reason that this is taught in Math 136 is because like the next progression in math sequence would be to take calculus. And in calculus, we want to talk about simplifying things and doing these things called limits. And sometimes you got to do the opposite of what you've always been taught. We've always been taught we like radicals in the numerator. In this problem, we want to get that h out of the denominator, basically. We want to get to cancel it out. So we're going to do the same thing we did on the last one. We're going to multiply by the conjugate, but now we're going to do it to simplify the numerator here. What would the conjugate of that numerator be? How do you find the conjugate of something? Well, if I do plus square root of x, you just change a sign in the middle. So get rid of some radicals, you just change the signs in the middle. And I'm going to do the same thing on the bottom. So just like the one we did, I'm not going to show a lot of work on this on the top, But tell me if you need more explanation here. But if I FOIL this out, if I take this square root times this square root, do you agree the square root's just going to go away, and I'm going to be left with x plus h? Because the square root of x plus h times the square root of x plus h, the square roots cancel out. Because one's a minus and one's a plus, do you agree that the middle part we don't have to do? I call that the oi of FOIL, the O and the I. So I'm just going to jump to the last part. The negative square root of x times positive square root of x is going to just give me negative x. On the bottom, I'm not going to multiply it out. I'm just going to write it as h times the square root of x plus h plus the square root of x. You're going to see why in a minute. And then I'm going to read to you out of your book so that I can kind of talk to you about this whole connection with calculus. So all I did was multiply by the conjugate of the numerator, simplified it, and now x minus x is going to cancel out. So I'm left with h over h times this. Could I cross those h's out now? Because I have h up here and h down here. That's kind of the point of rationalizing the numerator, is to cross that h out. Then your book's kind of, I don't know, you probably don't think this is funny, but your book says, it may seem as though we have accomplished very little, since radicals occur in the denominator. In calculus, however, it is of interest to determine what is true if h is very close to 0. Note that if we use the given expression, if we start from the beginning and we try to plug in 0 for h, we're going to get 0 in the denominator, and it's not going to tell us anything, right? Like if we plugged in 0 here, we would get some number over 0, which is very bad. We don't like that. But in calculus, we talk about getting really, really close to 0. Like what if we pick 0.1 or 0.01 or 0.0001? If now you plugged in 0 for h here, you've actually just done some calculus. You just didn't even know you were doing calculus to do that. So even in the old Math 136 books that I used to teach out of, they did this stuff with h because they want you to kind of sort of be used to this simplifying, because the next step would be calculus, and maybe you're not going to take it, but it's kind of cool. All right, so if you see stuff with h on your homework today, kind of the goal is get to the point so that you could cross the h out if you were wondering what it was if you plugged in 0 for h. But this is it. That's your answer. Math is crazy. All right, want to do another one with h in it? I think we should. Even if you all say no, I'm still going to do it, right? I don't really like the way this book says if h can equal 0. I think it should say get to the point that you could plug in 0 for h without being undefined. That's what I think the direction should say. That would make way more sense, right? Again, here's the issue. If I try to plug in 0 for h right now, I get 0 in the denominator, which tells me nothing. Doesn't help me at all in calculus. So what I want to do is I want to use algebra to hopefully cancel that h out, which means you just want to simplify. So like in the last problem, you saw square roots. So kind of the hint is, oh, square roots, I probably need to multiply by a conjugate. In this one, you see some fractions at the top. What do you think would be a good step to do in the first thing at the top of that problem? What should we do with those fractions? Common denominator. Because if we get a common denominator, maybe we can cancel that h out. Alright, so those are kind of the two things you should be looking for. Radicals probably mean conjugate. Fractions probably means common denominator. Do these denominators have anything in common right now? They have an x squared in common? So my common denominator, what can my common denominator be then? Brendan says they have an x squared in common. Does anybody disagree with that statement? Chase disagrees. Chase, what do you think they have in common? Nothing, right? X plus h squared is completely different than x squared because that x plus h is together. So my common denominator has to just be both x squared times x plus h squared. Right, but I said what do they have in common? No, they don't have x squared. If they had x squared in common, they would both have an x squared separately. Right? Maybe you just misunderstand my question. We'll just that's because they have nothing in common, that means this side just needs an x squared, and this side needs an x plus h squared. So I get x squared minus x plus h squared on the top. Whoa, that's not what I wanted. With me so far? What can we do next? Just move on. Definitely we could flip the h up because dividing by h is the same as multiplying by 1 over h. But that doesn't help right now because I can't cross anything out. What can I do to try to simplify? Could I simplify some of that? At the top, could I work the top out? So I'll take Chloe's advice. I'll rewrite it, but I'm gonna FOIL this out. So I'm gonna say that's x squared, and then I'm gonna FOIL that out and distribute the negative at the same time. So that's gonna become minus x squared minus 2xh minus h squared. Right? You got to be able to FOIL, multiply x plus h times x plus h. All over x squared times x plus h squared. And then instead of dividing by h, we can multiply by 1 over h. Can we do something else? Are you alright? Can we do something else over here? We're just doing some algebra here. Right? That's going to cancel out. The whole goal is I want to be able to get rid of this h in the denominator, because if I plug in 0 for h, I don't want it to give me an undefined problem. So the whole goal is to do some algebra so that we can cancel that h out. So look what's left in the numerator up there. Alex? Could I factor an h out of that and have negative 2x minus h over x squared times x plus h squared times 1 over h? And every single time that they give you a problem like this, the algebra will work that you can get to a point that you can cancel out that h in the denominator, so that what's left, if they asked you what happens when h equals 0, you can actually plug it in and give them an answer, instead of saying it's undefined, right? And again, you're not in calculus, so it's really hard to explain that whole idea. We've been in calculus for 2 weeks, and we're still explaining that idea, right? We're still kind of getting there of what this means, so I'm not really going to go any further than that, except for this is really almost calculus. So my answer here would be negative 2x minus h, and yes, if you really want to take the negative out, you can, over x squared times x plus h squared. Someday soon, my calculus kids are going to learn that's the definition of a derivative. But that's like chapter 3. A derivative. Calculus. I know. Okay, so we got the radical part, multiplying by conjugates. We got the h stuff. Now we get some fractional exponent stuff, alright? So let's do one more. That looks really scary.
Okay, we're not doing this.
Just write it down. It's not. It looks way worse than it is. I don't choose it. This is the great thing about teaching in my class. They tell me what to teach. They make the test, so you can't even blame me anymore. I do, actually. I would do it differently than how the book does it, but maybe the way they're doing it is easier. I feel like they could have simplified this a little bit. They put extra stuff in there just to make it look scarier. And hopefully as you're writing this, you'll see, oh, I could simplify that a little bit. We could, and it's still ugly, but yes, we could. So after the shock factor wears off of how terrible this looks, look at that denominator. Could we simplify that denominator and make it look not as bad? Yeah. What would it be, Zach? Well, and what would it be? Like, if you have a power to a power, what do we do with those? You just multiply that. So 1/2 times 2, or that's like the square root squared. Like, it's just 2x plus 5 in the bottom. So I think we could make this better right away by just saying in the bottom, that's just 2x plus 5. They just made it look scarier. In the top, there's not a lot we could do right now, but in that second term, they threw a 1/2 and a 2 in there. If we take 1/2 times 2, isn't that just going to equal 1? Like, that was just unnecessary, right? 1/2 times 2 is just 1, so I'm just going to cross that part out. And then you kind of have some choices, all right? One choice would be, Chloe says we could change all these 1/2 to square roots if we wanted to. I personally like the exponents better because I can use my rules of exponents. So I'm going to keep it exponents, but you could change it to radicals. Another option could be, we could deal with that negative exponent by making a fraction up here. That's what the book does. Another option is we could factor out fractional exponents. I don't know if we're ready for that yet, but I call that crazy factoring. In calculus, we do crazy factoring a lot. So let's try the fraction way first, and then we'll see how you feel about it. All right, so I'm going to rewrite this as 3x squared times 2x plus 5 to the 1/2. And you can do square root just as easily. And then just kind of cleaning this up, that canceled out. I'm going to move this 2x plus 5 to the 1/2 to the bottom, because I got rid of my negative exponent, which just leaves me an x cubed here. With me so far? And again, there's more than one way to do this here, and so I don't really want to, it'll take forever if we do all 3 ways. I just want to kind of talk about them, and then we can try one, and then we'll see what you want to do on there. One option would be, if we have subtraction on the top with a fraction, could we just get a common denominator here, like we've been doing? It's just uglier. We could get a common denominator, and then we could flip that up, and then we could simplify it just like we've been doing. It's just a fractional exponent. Yes? Another option, we could multiply the top and the bottom by this fraction. If you multiply everything in the top and everything in the bottom by that, is that going to work? That would work too. Don't write this down yet because we'll decide. If I multiply this whole thing by 2x plus 5 to the 1/2 on the top and 2x plus 5 to the 1/2 on the bottom, would that cancel out that fraction right there? So that's kind of a way to get around a common denominator, is if you just multiply the top and the bottom by that. I don't know. Do you want to do that, or you want to just do a common denominator? Because that's what we've been doing. I think this seems like less work, but you have to remember that you have to multiply everything in the top by that. So don't just cancel out this with this and forget that it also goes over there. All right, so it's like you're distributing that to everything. But just know a common denominator, and then flipping up your fraction, you're going to get the exact same answer. I'm going to make this go up a little bit. So on the top, if I take this times this, I'm still going to have 3x squared, yes? But what is 2x plus 5 to the 1/2 times 2x plus 5 to the 1/2? Yeah, because you just add those exponents, or it's like a square root times a square root. Like, it gets rid of the fractional exponent. It's just 2x plus 5. So that's super great. And what about the second one? If I take this fraction times 2x plus 5 to the 1/2, the reason I did that is this is in the top and this is in the bottom, right? So that's just going to cancel out. So I'm just going to be left with minus x cubed. How great is that? And then on the bottom, that's a nice voice. What happens when I take 2x plus 5 times 2x plus 5 to the 1/2? What do I do with exponents when I multiply and they have the same base? Add them. So this is a 1. This is a 1/2. What is 1 plus 1/2? 3/2. Which is 1 and 1/2. We just like improper fractions. Do not cross this out with this, because this is addition and subtraction, right? The subtraction sign right there doesn't let you do that. The only thing you have left to do now is you could simplify the top here, right? That would become 6x cubed plus 15x squared minus x cubed. So 6x cubed minus x cubed would be 5x cubed plus 15x squared, which technically we could factor that as well, but I'm not going to. Oh wait, is it not 2x plus 5, is it? No, it's not. It's freaking out. Yeah, we could factor the top if you wanted to. Hopefully we don't have this. You are going to attempt it. Don't freak out by how scary it looks. Alright? Like they always throw extra stuff in. Just remember you can multiply the top and the bottom as your common denominator. Good news is I didn't give you any homework problems if it makes you feel any better, okay? Okay. I'm moving. 44 and 46 have the H's in them. 49 is conjugates. And then 70 and 72 and 76 are the uglier ones. But just attempt those and try them. It's only 6 problems. Hopefully we'll be taking the AccuPlacer tomorrow. I gave you that piece of paper forever ago with sample problems on it, didn't I? A long time ago. If you need a new one of those and you want to look at it, I can give that to you. If you're signed up on my Remind 101, I will send out a message tonight letting you know whether it's AccuPlacer tomorrow or quiz tomorrow, because I just really don't know if I can't get my AccuPlacer information. Like I have to be able to get you logged in. Right now I don't have that information. Yes, which is why I just emailed Mr. Love and asked him if he had the information. So yes, it is. We will just take the AccuPlacer in here using the Chromebooks. We'll just have to do it next week. Like we just don't like you can't do it outside of school because I have to proctor it. So we'll just have to do it next week. And last I checked, you still want to